Welcome back, everyone. Hopefully you're feeling refreshed. For the last part of this lecture, we're just going to do a bunch more examples of establishing trig identities. And this one, again, just like for the one that I ended the last video with, I'm going to do this in a couple of different ways. Looking at the left side of the equation, that's definitely the more complicated side. That has many more options of things to do. So I'll start off with my left side of the equation. And then I'll try two different things, and I'll show you that both of them can be used to turn the left side of the equation into the right side of the equation, which is kind of nice here. So here I've got my 1 minus sine squared over 1 minus cos squared. So my first plan here, and hopefully maybe you're thinking this as well, since we have a sine squared theta, we know that sine squared theta is the same thing as 1 minus cosine squared theta. That's, of course, our old friend, the Pythagorean identity. So that's my idea here, is I'll turn that sine squared theta into 1 minus cosine squared theta. And the reason I'm doing that, why I thought about doing that, not just because I saw a sine squared, but because I'm thinking about where I'm going. And the right side of the equation doesn't have any sines in it, so it makes sense to get rid of the sines and turn them into cosines if possible. So that's what I've done here. Now, the next thing that I noticed for my numerator, 1 minus cosine squared, that's a difference of squares. 1 minus cosine squared is 1 minus cosine times 1 plus cosine. And then we have something very nice happen, which is at that point you can see that the denominator, the 1 minus cosine theta, can actually be canceled out. This is a good sign because notice on the right side of our equation we don't have a denominator, which means that at some point that denominator needed to go. And it looks like that now is the spot where it does. So what are we left with is just the 1 minus and then the 1 plus cosine of theta. So we have 1 minus and 1 plus cosine theta. And when we simplify that, carrying that negative through the bracket, the 1 minus 1 is gone, and then we'll have minus cosine theta, which of course is the right side. So we've shown that the left side is equal to the right side. We've established our trig identity, and we can feel happy about that. Now, that's only one way that we could work that out. I mean, there's a lot of other different options that exist. And so another option is, instead of me taking that numerator, sine squared theta, and using a Pythagorean identity, I might instead decide to look at that denominator, 1 minus cosine theta, and I'm going to do that technique where I'll multiply top and bottom by the conjugate so that I can turn the denominator into a difference of squares. So let's see what happens here. So another option is, so I'll say or, we could start with the left side, which is 1 minus sine squared theta over 1 minus cosine theta. And so my plan here is I'm going to take this fraction that I have and I'll multiply top and bottom by the conjugate, by 1 plus cosine of theta. And the reason why I'm doing that, of course, is when I look at the denominator, 1 plus cosine theta times 1 minus cosine of theta, that these two things will multiply together to give me 1 minus cosine squared. A minus b times a plus b gives me a squared minus b squared. So when I simplify things on the next slide, we'll have 1 minus sine squared theta times the 1 plus cosine theta, that'll be the numerator. And the denominator was 1 minus cos times 1 plus cos, which is 1 minus cosine squared. Now, this is where, again, Pythagorean identity comes into play. I'm looking at that denominator, and 1 minus cosine squared is the same thing as sine squared. So instead of saying 1 minus cos squared in the denominator, you could say sine squared instead. And then, nicely enough, the sine squareds cancel, which means that we're left with 1 minus 1 plus cosine of theta. And then carrying the negative on through the brackets, we get negative cosine of theta, just as before, which of course is our right side. So again, left side equals right side. This was just two options of what you could do. There's lots of different options that otherwise would be possible. So here, another option, which I'm not going to work out, I'll leave that for you to do for fun. You'll notice that you've got two terms, one term and another term that are being subtracted from each other. One of them's a fraction, one of them's not. You could make the term on the left side into a fraction. So 1 you could turn into 1 minus cos theta over 1 minus cos theta, and then maybe apply some sort of delightful trig identities after that and see what you get. And that's not the end of it all. There's lots of other things that you could do instead. So I want to work on a few more examples, though. I don't want to belabor this one too much. This one, we've got secant minus cosine equals to sine times tangent. And here, left side or right side both seem reasonable to start with. I know for the right side, I might think about turning tangent into sine over cosine. Then I'd see maybe what I could do after that. On the left side, I'm seeing secant and cosine. I'm thinking kind of the same thing. Secant, I would turn that into 1 over cosine. I'm going to start with the left side. Why not? So the left side, which is secant of x minus cosine of x, I'm going to turn the left side, instead of secant, it'll be 1 over cosine. And then I'm going to make a common denominator. This is, I've got a fraction minus something that's not a fraction, and I can turn that into a fraction, the second expression, by multiplying top and bottom by cosine of x. So I'll have 1 minus cos of x minus cos squared over cos of x. And now that you've got two fractions with the same denominator, you can combine the two. So taking the two terms and putting them both under the same denominator of cosine of x, you would have in the numerator 1 minus cos squared, and in the denominator you've got cos of x. Now this is a good spot to go back and think about, oops, not theta, huh? It was cosine of x. Try to be consistent with your variables. There we go. So going back and thinking about where we're getting to eventually, we want the right side to be sine times tangent. And if I'm looking at what I have now, I'm not really close to that. I've got just a lot of cosines. But I know I could make sine happen, because looking at the numerator, I've got 1 minus cosine squared, and I know with my Pythagorean identity that that's same thing as sine squared. So this is really the same thing as sine squared x over cos of x. And then now I know where I need to go, because if we're thinking about we want this to be sine times tangent, the numerator is sine squared, which is sine times sine. And sine over cosine, that's tangent. And so there we go. We actually have sine of x times tangent of x, which is, that was the right side we were trying to get to. So therefore, the left side is equal to the right side. We've established that trig identity. All right, let's do another one. This one, we've got some fun things here, tangents, cotangents, and on the right side, sine squared minus cosine squared. I'm thinking on the left-hand side, that's definitely the more complicated side to work with, so that's where I'm going to begin. And I'm looking at the left side. So tangent minus cotangent over tangent plus cotangent. I'm looking at the right side, and I want it to look like the right side, which is some sines and cosines. And so my plan here is I'll take those tangents and cotangents and rewrite them as sines and cosines. Tangent is sine over cosine. Cotangent is cosine over sine. That was supposed to be a minus. Try that again. There we go. So I've rewritten things in terms of sines and cosines. Tangent is sine over cosine, cotangent is cosine over sine. And now this is a kind of a fun flashback to the beginning of the term when we were simplifying expressions like this, these complex fractions, fractions within fractions. Remember, the idea to simplify this was to look at these fractions that you have whose denominators are cosine and sine, cosine and sine. If you were to multiply top and bottom by sine and also multiply top and bottom by cosine, that would get rid of the denominators that we would have. It would make this no longer a complex fraction. So first thing that I'll do, if you multiplied everybody by cosine, you would be able to get rid of the cosine here, the cosine there. This would become cosine squared, and that would become cosine squared. If you multiplied everybody by sine, you would have sine squared. This sine would cancel. You would have sine squared, and that sine would cancel. So when we multiply top and bottom by sine and also by cosine, what we wind up with is, on the top, sine squared minus cosine squared, and on the bottom, sine squared plus cosine squared. So just to recap where this is coming from, again, I multiply everybody top and bottom by cosine, so that gets rid of that. That makes this squared. That gets rid of that. That makes this squared. I multiply everybody top and bottom by sine. That makes this squared, gets rid of that, makes this squared, get rid of that. So we're left with, in the numerator, just sine squared minus cosine squared, and in the denominator, sine squared plus cosine squared. Which, notice, that's getting us one step closer to what we want. We have sine squared minus cosine squared as our final goal, and we already have, in the numerator, sine squared minus cosine squared. Oh, and there we go. In the denominator, there's our old friend, our Pythagorean identity, coming back yet again. Sine squared plus cosine squared in the denominator, that's just 1. So we do have sine squared minus cosine squared, which is the right side. That was the side we were trying to show that the left side was equal to. So therefore, there we go. Left side is equal to the right side. Okay, let's do one last one. And so for this one, a lot of these things of what to do next, it's suggested by the things that you have. So here I'm looking at the left side, and I see two fractions. And I know if this wasn't a trig question, if you see two fractions, you'd probably want to make common denominators and combine them into one fraction. So that's going to be my plan here. I'll start with the left side. So 1 minus sine u over 1 over 1 plus sine u. And I'm going to make a common denominator, and I'll do that by, for the first expression, top and bottom multiplying it by 1 plus sine u. So you'd have 1 plus sine u on the top and 1 minus sine u times 1 plus sine u on the bottom. For the second expression, I'll multiply top and bottom by 1 minus sine u, so that I would have 1 minus sine u on the top, and then I would have the same denominator. So actually what I can do is say, well, these would all be combined together over that same common denominator of 1 minus sine u times 1 plus sine u. Now, next thing that we'll do, of course, is hopefully notice that the denominator, 1 minus sine u, 1 plus sine u, that multiplies together to give you that lovely difference of squares. So we actually have a few things that we can do in one move here, which is number one, in the denominator, that is just 1 minus sine squared u. And in the numerator, you have a couple of things that cancel. The plus sine u and the minus sine u cancel, and so we're just left with 2 in the numerator. And that's getting us very close to where we want to be, because if we're looking at the right side is 2 secant squared, and we've got the 2, and so that's one step closer to getting to the right side. Now, I'm looking at the denominator here, and the denominator is 1 minus sine squared, and again, that's our old friend, the Pythagorean identity, coming back again. 1 minus sine squared is the same thing as cosine squared, so we have 2 over cosine squared u. And of course, cosine is the same thing as, reciprocal of cosine is the same thing as secant. So instead of 2 over cosine, it would be 2 times secant, or rather 2 times secant squared, which is exactly what we wanted to show. We wanted that right side to be equal to 2 secant squared. We wanted the left side to be able to be transformed into that. And that's what we did. We took the left side and we transformed it until it was equal to the right side. And so therefore our left side and right side are equal to each other. We've established our trig identity. All right, good work, everyone. And this is where we'll pause. And when we come back, we will start talking about an 8.5 angle sum and angle difference identities. There's lots to talk about in 8.5. But this is the end of 8.4, the end of our trigonometric identities discussion.